Hello viewers, you're welcome to Asomnofu online math class. Today, I'm going to take you on the topic distance along the meridian. If this is your first time of viewing, kindly consider subscribing to my channel so that you don't miss any content. Okay, now, in our previous video on these latitude and longitude, we've been discussing the distance along the latitudes or parallel of latitudes or the equator. So this time around, we want to discuss the distance along the meridian. So look at the question we are having here, and the question says that x is on the point 30 degrees north and 40 degrees east, y is 50 degrees south, 40 degrees east. Now, these are two places on the Earth's surface. We are now asked to find the distance between x and y. Before you can find the distance between this x and y, you've got to draw the diagram to illustrate the location of both x. So now, here is our equator. This is the prime meridian. You have a meridian here and another meridian here. Now, we want to get the location of point x and point y. Good enough, both x and y are on the same longitude, which is 40 degrees east, 40 degrees east. Now this is east. East is at the right hand side, so let's assume that this line is 40 degrees east. Now for x is on 30 degrees north, so let's say that this is the 30 degrees north, something like this. Let's assume that this is 30 degrees north here. Okay, 30 degrees north, and this is the latitude where it intersected this longitude at this particular point. So this point can be called the x because the longitude and the latitude, this is for 40, they intersected here, so this is where we have our x. Now for y is 50 degrees south. South is down here, so I can come here and form my south. Let's assume that this is a latitude here, so and I can call this point 50 degrees south, for instance. This is where they intersect also the latitude and longitude. So here is now y. Now tracing everything to the equator, to the center of the equator, we can now see that this length of arc is now the required distance between x and y. So we can form a shape like this. We can form a shape like this, where this is our theta, this is our y, and this is our x. Okay, now this length of arc is the distance between them. But if you look here very well, you see that they are on different points and the angle has spread out. Okay, now because they are on different points, the north and the south, you've got to add. Therefore our theta will now be 30 degrees plus 50 degrees, which will give us 80 degrees. This is our theta, the 30 plus 50. Okay, this 30 plus 50, they're on different points. Assuming it is not north or south, we've got to subtract. But once they are on different points, you see that the angle will enlarge. Okay, that's why we are adding. And you know, in your circle theorems, you know that the sum of angles in a circle is 360 degrees, and also the length of arc of a circle is theta over 360 times 2 pi r, where r is the radius of the earth. Okay, so we shall have distance xy will now be theta. Our theta is now 80 degrees. 80 degrees over 360 degrees times 2 pi is always 22 over 7, then times 6,400. So we are going to use calculator to compute this. Now, without wasting much time, I've just to say 80 times 2 times 22 times 6,400. Sharp, it will give us 22528,000. All over 360 times 7 is around 2520. So we are going to divide this by 2520. We shall get 8,939.7 approximately kilometers, approximated to 1 decimal place. So this is the answer, the distance between x and y measured along the meridian or the great circle. So if you've enjoyed what you've watched, kindly subscribe to my channel so that you don't miss any content. Thank you.